This meeting is being recorded.
For problem 32 from chapter 20, we're once again tasked with proposing reagents that could be used to create these following transformations. So specifically, we're tasked with finding an efficient synthesis for each of these. Um, so I'll give you at least one example of ways to accomplish these transformations, but note that there can be one or more other solutions. So let's take a look at part A here. So we see that we have this starting material here, this carboxylic acid, and we want to end up with this alcohol product. So if we were to just treat this, say we first created the acid chloride here, right, of this phenyl uh, carboxylic acid. So we created the acid chloride, then we treated that with ethyl magnesium bromide and an acidic workup. We would produce the wrong product. We would produce an additional ethyl group. And that's what we see above. So we can't convert this to an acid chloride and then use these sets of Grignard reagents, but what we can do is using thionyl chloride, convert this first to that acid chloride, and then in a subsequent step, in this second step here, we can then use the sterically hindered dialkyl lithium cuprate compound here. So this will only attack the acid chloride once to install one ethyl group. So this would accomplish, of course, with aqueous acid as well. Oh, I'm sorry. In our last step, we'll add our aqueous acid to convert after we reduce this using lithium aluminum hydride here and acid to our alcohol product. So again, we only wanted to install one of these groups, so we use this lithium cuprate reagent instead of the Grignard reagent because we would install two ethyl substituents. So then in our last step, we're going to reduce using lithium aluminum hydride and aqueous acid. All right, so let's take a look at B here. So we have our bromobenzene. In our first step here, we can convert this to a Grignard reagent using magnesium. So now we have this magnesium, phenyl magnesium bromide, Grignard reagent. Then if I react that using formaldehyde in this step here, and acid, I can generate this intermediate here shown, our benzyl alcohol, right? So benzyl alcohol. All right, and then we take that intermediate, and if we react this with either an acetic anhydride or an acetyl chloride here, and pyridine, we can see our final product. This portion here is installed on that alcohol group here where that hydrogen was. All right, so that's our set of reagents that could be used for part B. Now in part C, we're going to see in our first step here, we can convert our nitrile through hydrolysis to a carboxylic acid. So we would use aqueous acid and heat in this first step. Then we have our carboxylic acid intermediate. Then if we were to treat that with thionyl chloride, SOCl2 here, we could generate this acid chloride intermediate. Then in this step, now we can treat in two parts here with excess. We just need to install methyl, so we'll have this Grignard reagent here, methyl magnesium bromide, with excess of that, and then an aqueous acid workup, we would produce this alcohol here. Notice that we've installed the two methyl groups there. And then in this last step, we can use, again, an acid chloride shown here and pyridine to add on this portion here. And that's how we would generate our final ester product.